All right, people. Let me know in the chats if I am perfectly audible and visible. So, welcome to this beautiful channel. That's Unacademy NEET English. So, guys, today we have an important session over here. That is the laws of motion. That is the laws of motion. And my dear friends, I would want everybody of you to hit the like button if you have not liked the session yet. Okay, we are going to start this particular chapter. It's one of the important chapters when it comes to the NEET examinations. Okay, so you guys can expect, we say, 2 to 3 questions from this particular chapter. Okay, minimum of, we can say, 2 questions from this particular chapter. Now, guys, I will be starting from the basics. I will be starting from the scratch so that each and every single point is covered over here. Okay. And before that, I would want everybody of you to tell me in the chats that if I'm perfectly audible, visible to each and every single student. And let everybody join. Then only we are going to start this particular chapter over here. Okay. Good evening, guys. If you have not liked this session, and I would want you guys to hit the like button, okay? Because liking this session is extremely mandatory, because this is basically marking the attendance. Yes, you have attended the session, so that's why we say it is mandatory. So how is everything going? How is your NEET preparation going? Basically, this series is for all those students who could not afford to join our Phoenix batch, okay? So for those students, we have this particular series running on YouTube, okay? Every single thing will be covered. Each and every single thing will be taught, okay? So from the basics, from the scratch. If you haven't studied this chapter before, I am 100% sure that you would be able to understand this. That is my guarantee. When I give the guarantee, means everything is sorted. Okay. So let's dive into this particular chapter. Let's not waste the time and let's basically start this particular chapter over here. Okay. Let's start this particular chapter over here. My dear friends, listen to me very carefully. When it comes to the laws of motion chapter, we say, here we talk about the forces in this particular case. In this particular chapter, we talk about the forces. Okay. Now, my dear friends, the very first topic that we need to talk about over here is that is the state of rest and state of uniform motion. Understand very carefully whatever I am going to say over here. I'll be starting from the scratch. Guys, listen to me very carefully. See, when it comes to the chapter kinematics, let's suppose I have got a car over here. All of you understand this. I'm starting from the scratch. Let's suppose I have got a car over here and I say this car is moving in the forward direction. Okay. I say it will have some velocity. Sir, it will have some acceleration. Sir, it will cover some displacement distance. All of these things we talk in kinematics. But when it comes to the laws of motion chapter, understand this. Let's suppose I have got the block over here, okay? I say I am applying the force on this block. Forces. If we apply the force, it will accelerate. How many forces are acting on the body? So in nutshell, here we will be discussing about the forces, okay? Before that, my dear friends, we are going to discuss that is state of rest. We are going to discuss state of uniform motion. Okay. Guys. From very basics, understand one thing. If I have got a block over here, I say this block is at rest. What does that mean? That means the velocity of the block is 0. It is not changing its position. Okay. Sir, this is at rest, means this is not changing the position. So that's why we say this is at rest. My dear friends, if velocity of the body is 0, we say the body is said to be at rest. And if the position of the body is not changing, we say it is at rest. Okay. Now. Then we have the state of uniform motion. Guys, see, Let's suppose I have got a block over here, okay, or I have got a car over here, okay. Let's suppose I have got a car over here. And this car is basically moving with some velocity, sir. This is a constant velocity over here. Okay. Guys, understand very carefully. This car is moving on a road in which no friction is present. Means road is not going to stop this car. Why? Because that is a frictionless road. It will keep on moving. If I say net force on this block is 0. Okay, guys. If I say net force on this block is 0. Sir, what does that mean? Means if somebody is applying on this block force in this direction F, and another one is applying the another force on the opposite side F. So this F will cancel with this F. This is what we call the net force as 0. Okay. So if net force is 0, no force is acting on this block, we say it will keep on moving forever. So we say it is in the state of uniform motion. Uniform motion means when the body has constant velocity. And if net force on this block is 0, we say it will remain in the state of rest forever. This is the basic thing that I am saying. If this is moving with a constant velocity, net force is 0, it will keep on moving forever with the same velocity. Now, if you apply some force, okay, net force is not 0. Maybe its velocity will change. Tell me in the chats, is this clear till over here? If the body is at rest, if the velocity of the body is 0, we say body is said to be at rest. If the body is moving with constant velocity, we say it is the state of uniform motion. Guys, tell me in the chats, is this clear? Tell me in the chats, is this clear? I need to know in the chats. I would want everybody of you to tell me. And guys, I would want you guys to hit the like button as soon as possible. Make the like count 100 plus. That is very much mandatory. Is this clear? Okay. I told you two statements. Body is moving with constant velocity. It is uniform motion. Body is at rest. Body's velocity is 0. It is at rest. If net force is 0, it will remain at rest. If net force here is 0, it will move with the same constant velocity. Yes, sir. Now see. Let's move on to the next slide. These two states of a body are the natural states of the body. Either the body can be at rest or it can move with a constant velocity. That's why we call them natural states of the body. We say no net force is required to keep the body in these two states. Okay, that's what I said. Net force is 0, it will remain at rest. Net force is 0, it will keep on moving forever with the same velocity with which it was moving. Okay, like this is the same example which I have given. Now guys, we will be starting with now the first law of motion. I know there are some forces like normal reaction, weight, everything will be sought. I have my own sequence. I follow this sequence. Let's start with the first law of motion. Okay, that is Newton's first law of motion. Guys, see. What does Newton's first law of motion actually say? Listen to me very, very, very carefully. I'll make you understand over here. Guys, see. Let's suppose I have got a block over here. Okay. And I'm saying this block is at rest, means it is not moving. I say if the net force on the block is 0, guys, net force on the block is 0, means if some force is acting in this direction, same force will be acting in the opposite direction, then only we say net force is 0. We say if net external force on this block is 0, tell me, will the block change its state of rest? Sir, no. It will remain in the rest forever. So we say it will remain in the rest forever. Yes, sir. Now guys, let's suppose I have got, this is the statement number 1, statement number 2. Let's suppose I have got a block over here. And this block is moving with, guys, understand very carefully, constant velocity. So it is in uniform motion. If I say net force in this case is also 0, no external force is acting, or net external force in this case is 0, can I say it will remain, or it will keep on moving, it will keep on moving with the same velocity, with the same velocity forever? Yes, sir, it will remain in the state of uniform motion. Yes. Third point I'll write over here. If I have got a block over here, my dear friends, I say this block has a proper direction, uniform direction means this block is moving in the forward direction. Yes, sir, it has a uniform direction. It is not moving in a curve. So it is moving in forward direction. In this case also, if I say net external force is 0, like if somebody wants to deviate this, distract this, I say he can apply the force something like this. If this net external force is 0 here, if net external force is 0 here also, can I say it will not change its direction? It will keep on moving in the same direction forever. Hey bro, somebody is applying force from this side, another one is applying force from this side. We say both the forces will cancel. It will keep on moving forever. First one, if the body is at rest, net force is 0, it will remain in the rest forever. If the body is moving with constant velocity, net force is 0, it will keep on moving with the same velocity forever. Third one, if the body has a proper direction, one unique direction, net external force is 0, it will have the same direction forever, it will move in the same direction forever. Now guys, this is what we call the Newton's first law of motion that I explained. Let's now talk about the definition. Everybody wants to keep its state of rest. If I have a block, everybody wants to keep its state of rest, uniform motion. Everybody wants to keep in its state of rest and uniform motion until and unless it is acted upon by some external force. It says that if the body is at rest, it will remain in the rest forever until and unless some external force comes. External force value is not 0, then only it will change the state of rest. Every body wants to keep its state of rest, uniform motion, until and unless it is acted upon by some external force. Guys, please give me the signal in the chats that you understood this. Everyone means everyone. I would want you guys to give me the signal in the chats that you understood this particular thing, what I said. Okay? So, if we have to change the state of a body, we must apply the external force. If we have to change the state of a body, we must apply the external force. Okay? Like. Sure, I have given the example. If the body is at rest, if net external force is 0, it will remain at the rest forever. Okay? If the body is moving with a constant velocity, net external force is 0, it will move with the same velocity forever. If the body is moving in the proper direction, uniform direction, we say it will keep on moving in the same direction. Its direction remains same until and unless some external force acts over here. Yes, so this was all about, we say, Newton's first law of motion. Basically, Newton's first law of motion talks about the inertia. Inertia is a property of a body due to which it does not want to change its state. If it is in the state of rest, it wants to remain in the state of rest only. I say this marker is in the state of rest right now. Okay, it is because of inertia. Because of inertia, it will want to remain in this rest only until and unless some person applies some external force that displaces it. If the body is moving with a constant velocity, because of inertia, it would want to keep its constant velocity same. But if you apply the external force, its velocity will change. This is the Newton's first law of motion, and this is the statement over here. Everybody wants to keep its state of rest or uniform motion until and unless some external force comes and that displaces it. Done? Yes. Yes. Done, 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 done. Now guys, listen to me very, very, very carefully. Now comes the topic, that is what we call the momentum. Lot of people basically fail to understand this particular term, that is what we call the momentum. Lot of students fail to understand this particular term, that is what we call the momentum. But it is an extremely easy topic. If you focus over here for 5 minutes, you would be able to understand, that is my guarantee. Now guys, let's suppose I have got a wall over here. This is the wall in front of you. Forget about the definition. I have got a wall in front of you. Okay, it's a very strong wall. And I have got a truck over here. This is a truck moving towards the wall with some velocity. And mass of the truck is, we say, very large. Obviously, this is a big truck. It has a large mass. Okay. Yes, sir. It has a large mass. And then we have got a toy car over here. This is the toy car that we exactly have over here. Toy car means with which the small kids play. Okay, like you guys. So we have got a toy car over here. We know its mass is small. It has got a less mass, that is m. We say its velocity is, let's keep the same velocity. Tell me guys one thing. If this truck comes and hits the wall, do you think that it is able to break the wall, sir, easily? This is a big truck. If it hits the wall, it will break it. It will destroy the wall. Now, if this toy car hits the wall, do you think it would be able to destroy the wall? You say, sir, obviously no. Sir, why? Because it has less mass. Now see, is it the mass which is destroying the wall? No. Please wait. No. Sir, what is it? We say, guys, you are saying, sir, it has large mass. Because of this, it is destroying the wall because of mass. Okay. Let's keep the mass large. Let's decrease its velocity. If I am decreasing the velocity, now it is moving slowly, and it touches the wall. Do you think now it is able to break the wall? No. Why? Wall is also strong because its velocity right now is less. So in order to break this wall, the mass as well as velocity both should have the good value. So we say wall is destroyed because of both. We say mass as well as we say velocity. It is not only mass which is able to break the wall, it is both. Now, when you multiply both, when you take both of these, when you combine both of these, third quantity is being generated. That is what we call the momentum. So when mass and velocity is combined, we say momentum is created. Momentum is created. So my dear friends, it is not mass which is breaking. It is not velocity it is both are together are breaking this wall. So it is momentum. That's why we say momentum is defined as the product of mass and velocity. We represent this momentum with P. Like we say, sir, train is having a huge momentum. Train is having the extremely huge momentum. Why? Because Mass of train is extremely huge. Velocity of train is extremely huge. So that's why it is having the extremely huge momentum. So now, my dear friends, from now onwards, we say that person is coming towards me. So this guy is having a lot of momentum, means he has got a heavy mass and he's moving with a great velocity. So product of mass and velocity is what we call the momentum. Guys, please tell me in the chats if this is crystal and clear, and do like the session right now if you are liking it. Okay, do like the session right now. Tell me in the chats if everything is sorted. If everything is sorted. Tell me in the chats if everything is sorted, guys. Is this clear? With the fire emojis and the hearts. With the fire emojis and the hearts. It's been a very long time since I have seen all of those hearts that you guys used to send in the marathon sessions. Great, great, great. So we say simply, this will have less momentum. Sorry, this will have more momentum. This will have less momentum. Why? Its mass is more. Okay. Cool, cool, cool. Now guys, listen to me very, very, very carefully. Listen to me very, very, very carefully. So we say, when it comes to the momentum of a body, it is product of mass and velocity. Okay. So I say momentum is simply we say mass into velocity. Okay. Now, my dear friends, you can write the unit of momentum as, what is the unit of mass? That is kg. And what is the unit of velocity? We say it is meter per second. We measure it in meter per second. So SI unit of this momentum is kg meter per second. Okay. And when it comes to the dimensional formula, it is mLT minus 1. mLT minus 1. Okay. Now guys, you have got this particular question over here. Let's find the answer of this particular question. A mass is moving with 2 kg, sorry, a mass is moving with 4 meter per second. Its mass is 2 kg. We have to find the momentum. Sir, momentum is simply mass into velocity. Momentum is simply, what is mass over here? That is 2. And what is velocity over here? That is 4. Okay, and I'll write over here something like this. Mass into velocity. And if I just write over here, mass, that is, we say, sir, 2 kg. And when it comes to velocity, it is 4 meter per second. So it will be 2 into 4 is, we say 8. 2 into 4 is 8. And we say kg meter per second. This will be the momentum. Okay. Now, if I talk about the momentum of this, we say P is equal to M into V. We say momentum is, what is the mass of this body? Mass of this body is, we say, sir, 3. And my dear friends, mass of this body is, we say, 3 kg. Okay, sorry, 4 kg. Mass of this body is 4 kg. Okay, and velocity is 3 meter per second. 4 into 3 is, we say, sir, 12 kg meter per second. Now, guys, tell me one thing. This one is moving in the x direction. I have told you so many times. If a vector is in a, momentum is a vector quantity. Okay. If a vector quantity is in the x direction, positive x, we write it will be, sir, 8 I cap. Why? Because it is in the x direction. If it was in this direction, okay, if it was moving in the opposite, in the left direction, then I would have said minus I cap. We say I cap gives us the direction of the vector. For this, we write I cap means it is in the positive x. Now, if there is a vector which is in the y direction, then in that case, we mention with j. So I'll write over here, this is 12 j cap. So j tells us that momentum of the body is in y direction, plus y direction. Do you all agree? Tell me in the chats. Is this crystalline clear? Tell me in the chats, is this crystalline clear? Now, sure. Velocity is given as 2 I cap plus 3j cap. Mass is given this. We are supposed to find what is the value of momentum in this particular case. Guys, is this clear? Please, I don't want anybody of you to keep the confusion over here. Let me know in the chats. I'll clear it right now, right here. Okay. We have got a mass over here. We have got a mass over here. Mass is 3 kg. Okay. Velocity is 2I plus 3j. If we have to find the momentum over here, we say momentum is mass into velocity, product of mass and velocity. Velocity is a vector quantity, mass is a scalar quantity. So I can write over here, what is mass, sir? That is 3. What is velocity? Velocity put over here, that is 2I cap plus 3j cap. Sir, what is this ij you are saying? That's the reason we say, do not miss any of our lectures. I have completed this in vectors. If there is a vector in x direction, guys, see, wait, listen to me. If there is a vector in x direction, let's suppose this is a force acting on this block in x direction. Value of force is 10 Newton. How can we write this in vector form, sir? I write its vector form as 10 I cap. Means force, magnitude of force is 10 Newton and direction is I cap, means in x direction. If I say this is the force F2 is equal to 20 Newton, how do we write in vector form? We say I'll write F2 is equal to minus 20 I cap. Minus 20 I cap means in the negative x direction, backward direction. And now, if there is a force acting in y direction, so F is equal to 10 Newton. We say we write it F is equal to 10 J cap. J gives you the direction along y. Then if I say we have got a force F is equal to 6I plus 3j. Sir, what is this? This force is in the x direction as well as in the y direction. So I can write it something like this. This is x axis. This is y axis. So force will be something like this. It is in the x as well as y. So this can be, it can be something like this. It can be something like this. Now let's find the value of this. So we say 3 into 2 is, we say 6I cap. Then we say plus 3 into 3 is, we say 9J cap. So this is the value of momentum. This is the value of momentum. Okay. Okay. Is this clear? Is this clear? Please tell me in the chats. Is this clear, guys? Let me know in the chats if everything is crystalline clear. And guys, if you have not liked the session yet, I would want you guys to hit the like button. Next question. Next question we have got on the screen. Let's suppose you have got over here, mass. This mass is, we say, let's suppose 2 kgs. And in this particular case, you guys are supposed to find, I'll write the question over here. Find the momentum. Find the momentum of the mass. Find the momentum of the mass. You guys are supposed to tell me what is the momentum of the mass. Okay, what is the momentum of this body? Guys, see. Sure. Listen to me very carefully. Vectors are important, my dear friends. See, mass is 2 kg. Velocity of the body here is, we say, 20 meter per second. But at what angle? 37 degree. Guys, see. If I say, listen to me very carefully. We say, let's suppose we have got a vector something like this. This is V, okay? And V is how much? That is 20 meter per second. Okay. And this vector is making 37 degrees over here. Okay. Now, we have studied. If we haven't studied, then listen now. A vector can be resolved into 2 components. Cos component and sine component. X component and Y component. This vector can be resolved into 2 components. First one will be its horizontal component. Second one will be its vertical component. This is Vy. Okay. If we write its horizontal component, we say Vx will be, guys, see. If this is the angle, then we say this will be its cos component. Okay? Okay? A vector, remember, a vector can be resolved in two components. Directly remember it over here. Okay? This vector has effect in horizontal direction as well as in the vertical direction. That's what I'm saying. Now, if this is the velocity, guys, remember directly, a vector can be basically, we say divided into, or we say resolved into two components, this one and this one. Now, this component is what we call, that is V cos of theta. This component is V sine of theta. Okay. Let's find the Vx right now. Okay. So, Vx will be V cos theta. What is V? That is 20. Then we say cos of. This angle is how much? That is 37 degrees. Okay. Now, remember this trick, guys. If we have a triangle over here, guys, always remember this. And if the angle, this is 37 degrees. And if we have another triangle over here, this is what we call the 53-degree triangle. Directly remember this. If you have a triangle something like this 37-degree triangle and this angle over here is 53 degree, then remember this side of this 37-degree triangle is 3, this is 4 and this is 5. And here you have got this is 5, this is 4 and this is 3. Guys, see, compare this and this. 37 is smaller. In front of the smaller angle you have got smaller side. In front of the bigger angle you have got bigger side. Here is 4 and here will be 3. In this case, here is 3, here is 4. 5 will be same. Now tell me in this case, guys, what is the value of cos 37? Sir, cos means base by hypotenuse. Cos 37, base by hypotenuse, that is 4 by 5. So I can write Vx is equal to, that is 20 into 4 by 5. So 5 ones are, 5 fours are. 4 into 4 is, we say, sir, 16 meter per second. Okay, let's find the value of Vy. Sir, Vy is, that is V sine theta, that is 20 sine of 37. What is sine 37? Perpendicular upon hypotenuse. So that is 3 by 5. So 20 into 3 divided by 5. 5 ones are, 5 fours are 20. 4 into 3 is, we say, sir, 12 meter per second. Means this vector is resolved into this component and this component. Horizontal component has the value 16. Vertical component has the value 12. Now, you can also think it something like this. If the vector is resolved in two components, this one and this one, you can also say a vector, two vectors, if we join this and this, their resultant will be this. So I can write over here, this vector is equal to, this vector V is equal to this vector plus this vector. So that is Vx plus, we say, sir, Vy. Now what is the value of Vx over here? Sir, and Vx is in the x direction, so I write I cap. Vy is in the j direction, so I write j cap. So what is the value of Vx? That is 16, okay, I cap, plus what is the value of Vy? That is 12, we say j cap. Okay. Now guys, tell me one thing. You got the value of velocity. You have the mass. If velocity is given at some angle, in that case, you have to find its x and y component and then you can basically find the answer. So, can I write over here? Now, momentum is equal to mass into velocity. We say momentum is equal to, what is the value of mass? 2 kg, so I'll write over here that is 2. What is the value of velocity? 16I plus 12j. So I'll write over here 16I plus 12j cap. Okay. Now 2 into 16 is, we say, sir, 32I plus 24j cap. This is the value of momentum over here. Even you can find the magnitude of momentum also. Magnitude of momentum will be under root of this 32 whole square plus this 24 whole square. Guys, tell me in the chats if everything is crystalline clear. Tell me in the chats. Guys, tell me in the chats if everything is crystalline clear, and hit the like button, smash the like button, everybody. Every single time I see the lovebirds in the chats, okay, they are busy with their own work, okay. Chalo, it's good. I'm getting the good views, okay. But to all those aspirants who are very serious out there, I would request you to focus on here, okay, completely. And we will keep making fun of these students also. Chill, take a chill pill. So I would want everybody of you to focus over here. Whosoever is, we say serious about his NEET preparation. Okay. Now guys, listen to me very, very, very carefully. Listen to me very, very, very carefully. We have got a mass over here. And in this particular case, guys, listen to me very carefully. This is 2 kg mass. We say find the momentum. Find the momentum of 2 kg mass. And I have told you guys, if you ever get a velocity at certain angle, then you have to break it in 2 components. Guys, see, if velocity here is 10 meter per second, can I say velocity? This will be x. Guys. If angle is from this side, then you take this as, we say, cos component. If this was 37, then I would have said this is the cos component. It depends which one is the theta over here, which one you are taking the theta over here. Okay. So can I say if this is 10, this component will be as Vx horizontal, and this will be over here, that is 10 cos of 37 degrees. Can I say this component will be Vy is equal to, we say 10 sine of 37 degrees. Now what is the value of sine 37? Guys, recently I told you value of sine 37, that is 3 by 5. Sine is perpendicular upon hypotenuse, that is 3 by 5. So I can write over here, this is 10, and then I'll write 3 by 5. 5 ones are 5, 2s are 10. 2 into 3 is, we say, sir, 6. So Vy is 6. Let's find Vx, sir. Vx is, we say, 10. Cos of 37 is 4 by 5. So 5 ones are 5, 2s are 10. So 2 into 4 is, we say, sir, 8. So Vx is 8, Vy is 6. Now let's write the value of velocity. We say velocity is simply, that is Vx I cap plus Vy j cap, because this is in the y direction. Now I can write over here, what is the value of Vx? Vx is, we say, sir, 8 I cap. Then we say plus. What is the value of Vy? That is 6. Guys, see, if the vector is in the downward direction, we take its velocity as negative. We take its value as negative. So it is minus j. If it is in the upward direction, we take as plus j. So here, this Vy is downward, so it will be minus 6j. So I'll write over here, instead of this, I'll write minus 6j cap. Because upward means plus j, downward means minus j. So I can say this is the velocity. Now let's find the momentum. We say, sir, momentum is mass into velocity. So I can write, what is the value of mass? That is 2 kg. Velocity is 8I minus 6j. So now this is 2 into 8 is 16I minus 2 6 is 12j. So this is the value of momentum over here. Guys, is this clear? Is this clear? Is this clear? Great. I hope you are loving this session. Now let's talk about the change in momentum. Let's talk about the change in momentum. Guys, what does this change in momentum actually mean? See. Let's suppose if you have a mass exactly over here, okay? it is moving with a velocity v. And after some time, here when the mass reached, here its velocity became v dash. Tell me, is its velocity same or different? Sir, its velocity is different here. Here it is v. Let's suppose it was moving with 10 meter per second. Here it is moving with 20 meter per second. It may be something like that. What is the momentum over here? Sir, momentum, that is what we call initial momentum. Initial momentum over here is, we say, mass into velocity, m into v. What is the momentum over here? Sir, that is final. Finally, its momentum is mass into velocity. Velocity is v dash. Okay. So here momentum is mv. Here momentum is mv dash. Now, has the momentum changed from this point to this point, or is it is same? Sir, here it is mv. Here it is mv dash. Obviously, it is changed because velocity is changed. Now, can I say, when it comes to the change in momentum, I'll write over here, change in momentum. Change in any quantity we always write as final minus initial. So here change in momentum means delta P. This is how we represent change in momentum. That is delta P, large change in momentum. We say it will be, sir, final momentum minus initial momentum. Can I write over here delta P is, what is final momentum? mv dash. So I'll write over here mv dash minus, what is initial momentum? That is, we say, sir, mv. So you can write over here, this is, take mass common, and it is v dash minus v. So this is what we call the change in momentum over here. This is what we call the change in momentum over here. Final momentum minus initial momentum will be exactly the change. Guys, let me know in the chats if everything is crystalline clear. Let me know in the chats if everything is crystalline clear. Everyone means everyone. Please. Is this crystalline clear? Is this crystalline clear? Great. Now, let's come over here. We have got a question. I say, in this particular question, I ask you, find the change in momentum. Find the change in momentum. Find the change in momentum here. Guys, see. I have got a mass over here. Initially, it is moving with the velocity vi. That is 2i plus minus 3j. This is the velocity in vector form, guys. This mass is moving with this velocity initially. Okay, let's suppose here mass started from here with the velocity vi. What is the value of vi? 2i plus 3j. And after some time, when mass reached over here, its velocity became vf. What is vf? 5i plus 2j. Initial velocity, final velocity. Mass is, we say, sir, m. Mass is, we say, sir, m. We have to find the value of change in momentum. Guys, how do we write change in momentum? See, in the previous question, sir, change in momentum is mass into final velocity minus initial velocity. We say as delta P is simply mass into V final minus, we say, V initial. Okay. Can I write over here delta P is, what is the mass over here? That is 2 kgs. What is final momentum? Sir, that is in this particular final velocity. What is final velocity over here? Guys, write it something like this. What is final velocity? Sir, I'll write that as 5i. Then we say plus 2j. This is the final velocity of the mass. What is the initial velocity? Sir, minus V initial. V initial is, that is, I'll write 2i minus, we say, sir, 3j. This is the initial velocity. Now tell me, guys, can I write it something like this? 2. And we say this is 5i as it is, plus I write 2j over here. Now minus into plus is, we say, sir, it becomes minus, and now remove this bracket. So minus, we say 2i. Minus into minus is plus, we say, sir, plus 3j over here. Now tell me one thing. 5i minus 2i will be how much? You say, sir, this is 2 into 5i minus 2i is how much? 5 minus 2 is, we say, sir, 3i. Okay. Now 2j plus 3j. You have to add I with I, j with j. So 2j plus 3j is, we say, sir, 5j over here. Okay. Now how much is 2 into 3 is, we say 6i plus 2 into 5 is, we say, sir, 10j. So this is the value of change in momentum over here. This is the value of change in momentum over here. Is this clear? Is this clear? Guys, is this clear? Let me know in the chats. Everybody. Let me know in the chats. I would want you guys to tell me in the chats if everything is sorted, crystal and clear. And hit the like button if you have not liked the session yet. I would want you guys to do it as soon as possible. Okay? Great. Now, next. Let's talk about some of the cases. In which you have to find the change in momentum. Okay. We said these are the only 4 cases in which you would be asked to find the change in momentum. Sir, what are these cases? Let me tell you. First, you have got over here, let's suppose this is wall. This is a wall. Okay. Now, you are basically throwing a ball. Okay. Its mass is m and it is going with the velocity v and it is striking the wall. This mass is striking the wall. Okay. Now, once you throw the ball over here, the ball goes. Once it strikes the wall, it will not reflect back. It will not come back. Okay. It gets stuck over there. So we say final velocity of the ball becomes 0. Why? Because it stops over here. Initial velocity is v. Final velocity is 0 because it is not elastic. It does not come back. How to find the change in momentum over here? Guys, see in this case, how to find the change in momentum? We say when it comes to the change in momentum, we say that is, sir, that is final momentum minus initial momentum, pi minus p initial. Now, how do we write that? Sir, that is mass into v final minus v initial. This is how we write the change in momentum. Mass into v final minus v initial, v dash minus v. Now tell me, sir, here, what is the mass? Mass is m. And what is the final velocity of the ball? Sir, it will stick over here. It will not reflect back. So v final in this case is 0. So I say v final in this case is 0. Minus, what is the initial velocity of the ball with which it is moving? That is velocity v. So I can say it has got velocity v initially. So now m into 0 is 0. M into v is mv. So it will be, and minus over here it is minus mv. So in this particular case, perfectly we say inelastic collision. So change in momentum here will be how much? That is minus mv. In this case, change in momentum is how much? Minus mv. Next. Let's suppose you are throwing a ball of mass m with a velocity v and it is reflected back. When it hits, it is reflected back with the same velocity. How to find the change in momentum over here? You say, sir, change in momentum is, see, we say that is m into v final minus v initial. This is the general formula, guys. Now, can I write over here change in momentum is, that is m into, what is the value of final velocity? Guys. This is v initial and this is v final. And Remember always, I have told you this in the kinematics also. If the object is moving towards a right, in the right direction, we take its velocity as positive. If the object is moving towards left, we take its velocity as negative. We take its velocity as negative. Okay. Now, can I say final velocity here is negative? So it is negative v. Why? Because it is in the left direction. So here, what is final velocity, sir? Final velocity is minus v. What is initial velocity, sir? That is v. So then this is formula is minus and this is v. Minus v will be minus 2v. So it will come out to be minus 2mv. So this will be the change in momentum. This will be the change in momentum. Minus 2mv in the perfectly elastic collision. Next. Case 3. Guys, here, ball is moving with a velocity v1 and it strikes the wall. Okay. And it gets reflected. It is reflected with the velocity, we say, sir, v2. Here, velocity is not same. How to find the change in momentum? Can I say this is the initial velocity over here and this is the final velocity over here, and I write it negative? Why? Because it's towards left. So here I can write delta P is simply, that is mass into final velocity minus initial velocity. So we say delta P is equal to mass of the ball is m. Okay. Sir, what is final velocity? Final velocity is minus v2. So this is minus v2. Then we say this formula is minus v1. What is the value of initial velocity? That is v1. This is v1. You can take the negative common over here. This is negative m. Then we say v1 plus v2. You can write it something. Even when you multiply, it becomes minus v1 minus v2. So this will be the change in momentum in this particular case. This will be the change in momentum in this particular case. Great. Lot of students are sending over there, mentioning over there. Okay. Next. Let's suppose if the ball hits the wall, this is the wall. If the ball hits the wall at an angle of theta, and when it strikes the wall and it gets reflected something like this. Guys, see. We say mass is m, velocity is v. It gets reflected with the same velocity over here at the same angle. Guys, like it, you are throwing a ball something like this. It falls and gets reflected. Here it makes the angle theta, here it makes the angle theta. Hey, I'll teach kinematics also. Take a chill pill. Every single chapter I'll teach. That is my guarantee, okay? Chill. Focus over here. Now see, always remember guys, see. Let's suppose, I'll basically show you this. Let's suppose I have got a vector over here, something like this. This is a vector, okay? This is a v vector. I say this v vector will have two components. Sir, one is the vertical, if this is theta, this will be v sine of theta, and this will be, we say, v cos of theta. Okay. And I'll mention it from the upper side. This one will be v cos of theta. Guys, this is the velocity vector. Now, this velocity vector can be resolved in two components. This component and this component. Same. I say, then you have got something like this. This velocity component can also be resolved in, this is v sine of theta. And here, this is v also. This will be, if this is also theta, so this is v cos of theta. Okay. Now tell me one thing. Guys, tell me one thing. Sir, these two components, this component and this component, will cancel out each other. Why? Because they are in the opposite direction. We say here v sine theta and v sine theta will cancel will cancel each other, will cancel each other. V sine theta and V sine theta will cancel each other. Okay. V sine theta and V sine theta will cancel each other. And these two velocities, vectors are in the same direction, so they'll add up. And cos components will add up. Will add up. Cos components will add up. So now, how much is the net velocity over here in this particular case? I say, so we can say in this particular case, V net will be simply, that is 2V cos of theta, 2V cos of theta. Now guys, in this particular case, listen to me very carefully. In this particular case, you guys are supposed to tell me the change in momentum. Can you guys tell me in the chats? Can you guys tell me in the chats what will be the value of change in momentum in this particular case? What will be the value of change in momentum in this particular case? Okay, guys, see. Horizontal component, sorry, vertical components are cancelled out. So we say, here, this is the velocity I can say over here initially. This is the velocity I can say finally. Why? Because this is the only velocity that remains over here. Now forget about this and this. They are resolved in two components. This and this will cancel. Now, this is the initial velocity. Initial velocity has got V cos theta. And this final velocity also has got what? We say V cos theta in this particular case. So here, the change in momentum will be simply that is minus 2mv, we say cos of theta, minus 2mv cos of theta. M is the mass over here. Yes, lot of students are exactly writing over here in the chats. Okay. Is this clear? Guys, is this clear? Guys, tell me in the chats, is this clear? Everybody out there? Now, let's move on to the questions which will clear your, if you guys have any sort of confusion, that will clear out each and every single thing. That will clear all the confusions out, that's for sure. Guys, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Hit the like button as soon as possible. Make the like count to 200. Now. Guys, find the change in momentum of the ball. Guys, we have got a mass over here. It has got velocity V. And then it is reflected over here with a velocity V. Same velocity. Don't you think that this is the case which is exactly like this, which is the case exactly like this. Ball is coming, it strikes, then it is reflected with the same velocity but in opposite direction. So can I say in this particular case, what is the value of change in momentum, sir? Change in momentum will be simply mass into final minus, we say, sir, initial. So what is mass? Mass is m. Guys, what is final velocity? This is the final velocity over here. Guys, see, in this case also, if you take this velocity as positive, you have to take this velocity as negative. So here you can simply say it is with 2mv, minus 2mv, like it is exactly like the case, something like this. So here answer is minus 2mv. Tell me, what is the answer in this particular case? What is the answer in this particular case? Yes, is negative sign due to the direction of velocity? Yes, negative sign is due to the direction of the velocity. Tell me, guys. What is the change in momentum over here? Find the change in momentum of the ball. We say, sir, change in momentum is simply, we say in this particular case, that is mass, we say m, v final minus, we say v initial. Guys, what is the mass of the ball? That is 1 kg. Now see, ball is coming and it strikes the wall. This is the wall over here. Guys, it is moving with the velocity of, this ball strikes, it is moving with a velocity of minus 10 meter per second. Why? Because it is moving towards left. It is moving towards left. So I can say this is V initial and V final over here is plus 10. So V final in this case is, we say, sir, plus 10 minus. V initial over here is minus 10. So I'll write this is minus 10. So this will be 1 into 1 kg into 10 plus 10 is, that is 20. So here it is 20. In this particular case, the change in momentum came out to be, we say, sir, 20. Is this clear? Is this clear? Please tell me in the chats, everybody out there. Okay. Please tell me in the chats, everybody out there. Okay. Okay. This is plus 20. How negative in the previous one? Oh, sorry. It is positive. It is positive. My bad. Guys, this is the initial velocity. I'll show you. This is the V initial. And this is the V final. Guys, see. Let me clear this. If the ball moves in the right direction, we take its velocity as positive. If the ball moves in the left direction, we take its velocity as negative. If the ball goes up, we take its velocity as positive. If the ball falls down, we take its velocity as negative. These are the sign conventions. So here, ball is falling down, so means it is initial velocity. So initial velocity is minus v. It is falling down. And then it is going up. We say final velocity in this case is obviously positive. So can I write in this particular case mass into final velocity is, we say, sir, positive, minus initial velocity is what? Negative. So I say this is negative v. So now v plus v is 2v. So this will be 2mv plus 2mv. Sorry. Now is this clear? Is this clear? Please give me the signal in the chats. Please give me the signal in the chats. Everybody out there. Guys, I'll get some water. Just give me 5 seconds. Just give me 5 seconds. Now, guys, see. Let's talk before impulse. Let's talk about the second law of motion. let's talk about the second law of motion. I would want you guys to now focus over here. Let's finish the second law of motion. Let's finish the second law of motion. Guys, see. When it comes to the second law of motion, everybody over here, what does it say? Guys, see. Newton's second law of motion. See, guys. Let's suppose we have got a mass over here, okay? And this mass is moving with a velocity v. Okay, like a body is moving with a velocity v. And we say after some time, let's suppose delta t, its velocity became v dash. Its velocity changed. Okay, sir, how? This mass is moving with a velocity v. You applied the force on this mass. What will happen? Sir, on applying the force on this mass, we say its velocity will increase. It will move faster now. Now we say its velocity became v dash. Its velocity became v dash. What was the velocity initially? V. What is the velocity now? V dash. Why? Because of the external force. Now, can I say due to the F external, we say velocity of the mass changed. Velocity of the mass changed. Okay. Yes. Due to the F external, velocity of the mass changed. So, momentum of the mass also changed. Guys, because of the external force, we say velocity of the body changed. What is the momentum over here, sir? Here momentum will be mb, mass into velocity. Here finally momentum will be mb dash. Sir, because of the force, velocity changed. So because of change in velocity, momentum changed. So can I not say, because of the force, I'm directly saying there is change in momentum. So can I write over here? So it is external force which changes the momentum, which changes the momentum. It is external force which changes the momentum. How are we supposed to write that? Sir, we can write it something like this. F external is proportional to, we say, sir, delta P divided by delta T. Sir, what is this delta P? Delta P is change in momentum. Guys, see, in this particular case, could you please tell me what is change in momentum, sir? That is final momentum minus initial momentum. Sir, that is m into v final minus v initial. So this momentum delta P has been changed because of force. So we say force is equal to change in momentum upon change in time. So this is what we call the Newton's second law. Newton's second law says that rate of change of momentum is directly proportional to force. We say. So according to Newton's second law, we say a rate of change of momentum. We say a rate of change of momentum is directly proportional. To external force. A rate of change of momentum is directly proportional to external force. The more you apply force, more velocity will change, more will be the change in momentum. Okay. Yes, sir. Now guys, we say F is equal to delta P divided by delta T. This is also what we call the average force. Why, sir? Because what is delta P? Delta P is total change in momentum. Like guys, if you have got a mass over here, okay, and if you apply, this is the velocity. if you apply the force over here, because of this external force, I'm saying that velocity of the mass has been changed, that is v dash. Now, if you apply the force from here to here, you are continuously applying the force, continuously applying the force. So because of this force, guys, understand very carefully, because of this force, we say from here to here, momentum has been changed, and in what time? We say, sir, delta t. How much momentum has been changed? Delta p. Because of this force, the total change in momentum is delta p. Total change in time is delta t. Now, guys, if I say, you are applying the force on this mass, okay, velocity is v. Now, if I say, guys, from this point to this point, will there be small change in momentum or large change in momentum? Obviously, sir, from here to here, there is a huge change in momentum, huge change in time. So between this point and this point, very small interval. So we say it is dt, and here we say change in momentum is dp. So we can write it something like this. So we can say instantaneous force is what we call, that is dp divided by dt. What is this? This is nothing. Small change in momentum upon small change in time is what we call the instantaneous force. Like, see, you might have studied, we say, sir, average velocity is simply, that is delta s divided by delta t. Total change in displacement upon total change in time is average velocity. And instantaneous velocity is what? Small change in displacement upon small change in time. Same is the case over here. From here to here, we say total change in momentum is delta p. Total change in time is delta t. So the force will be, sir, this average force in total. But sir, at any particular instant, how much will be the change in momentum? Very small. How much will be the change in time? Very small. So how much will be the force? That is instantaneous force. I say this is the force at any particular instant. This is the force at any particular instant. Is this clear? Is this clear? Great. Guys, simply remember that if external force is acting on a body, because of that external force, there will be change in momentum. And force is equal to delta p by delta t. Now, guys, see. We say we say force is equal to, that is dp divided by dt. Force is equal to dp divided by dt. Okay. Now, guys, can I say as when it comes to the momentum is simply mass into velocity. So if you apply the external force on anybody, we say its momentum will change. Okay. So can I say over here, sir, this force will be, that is d by dt of, instead of p, I can write mass into velocity. Instead of p, I can write mass into velocity. Now, can I write this force as, guys, mass is constant. If this is the mass over here, okay, it is moving at the velocity v, you are applying the F external force over here. We say mass remains constant, its velocity will change. So take this mass out. So it becomes dv divided by, we say, dt. So I can write this force will be mass into, what is dv by dt? Sir, dv by dt in this particular case is, we say, sir, acceleration. In this is acceleration. Okay. So we say force is equal to mass into acceleration. We say this is the Newton's. This is the Newton's second law. When mass of a body is constant. Guys, means if mass of a body is constant, then only this is applicable. Otherwise, this is the Newton's second law, which is applicable everywhere, even if the mass is constant, if the mass is not constant. Okay, so this is what we call the Newton's second law, this one and this one. But this is the Newton's second law only when mass is constant. See, when I took the mass out over here because it was constant, then I differentiated this dv by dt. What is dv by dt? Rate of change of velocity with time is what we call the acceleration. Okay? Now. If I say, if we say if mass of a body is variable, if mass of a body is variable, can I say in that case force is equal to, I'll write dp divided by dt. This is the general formula, yes. So I can write F is equal to, I can write over here, this is d by dt of, that is mv, because momentum is mass into velocity. Let's suppose velocity is constant, take this out. So we can say F is equal to v, and then I'll write dm divided by dt. What is this dm by dt? dm by dt is a rate of change of mass. How fast the mass is changing over here. This is the Newton's second law when mass of a body is variable. When mass of a body is variable. Okay? And if I say if both mass as well as velocity is variable. Understand this. Guys. Can I say in this particular case, F is equal to dp by dt, dp divided by, we say dt. And here force will be, that is d by dt of mv. Guys, in this case, we say mass is variable. And in this particular case, we say this is variable. Mass is variable and velocity is variable. And you can use the u into v formula over here, differentiation of uv. How do we use differentiation of uv? What is the formula of uv? Sir, uv is, keep u as it is, differentiation of v, that is dv divided by dx. Then plus, keep v as it is, differentiation of u, that is du divided by dx. So here I can say F is equal to, first you keep the mass as it is. Then you say differentiation of velocity dv by dt. Then we say plus, keep velocity as it is, then differentiation of mass dm divided by dt. Guys, tell me, is this crystalline clear? All of these formulas are crystalline clear. Okay? All of these formulas are crystalline clear. Guys, tell me in the chats. Give me the signal in the chats. I would want everybody of you to tell me. Is this crystalline clear? Is this crystalline clear? Great. Now, let's move on to the questions. We have got the first question over here on the screen. A player catches a ball of 200 gram moving with a speed of 20 meters per second. If the time taken to complete the catch is 0.5 seconds, the force exerted on the player's hand is, it is like, we say a player is catching the ball. Okay, he catches the ball. So how much force the ball applied on his hand, that is what we are supposed to calculate in this particular case. Tell me the answer of this particular question in this particular case. Okay. Yes, F is equal to ma is only applicable for where force mass is constant. Tell me guys, what is the answer of this particular question that I asked you over here? Guys, tell me, a player catches the ball of 200 grams, okay, with a speed of 20 meter per second. Okay, if the time taken to catch the ball is 0.5 seconds, time taken is given over here. Guys, see, if you have to find the force over here, we say as force is simply that is delta P divided by delta T. This is the general formula. Change in momentum upon change in time. Just a second, guys. See guys, we say F is equal delta P divided by delta T. Sir, delta P is what? Change in momentum. How to find the change in momentum in this particular case? We say, sir, delta P is simply P final minus P initial. Guys, see. Ball is coming, okay? So finally we have taken the catch. When we take the catch, ball comes to rest. So means velocity of ball becomes 0. Velocity of ball becomes 0. If velocity of ball becomes 0 means I can simply say final momentum will be 0. Why? Because mass into final velocity is final momentum. Sir, what is initial momentum? We say, sir, initial momentum in this particular cases. Initial momentum in this particular cases. How much? How much? We say, sir, that is mass into velocity. How much is mass over here? That is, we say, sir, 200 grams. Okay. And I say, and divide it with 1000, it will come out to be in the kgs. 200 grams multiplied by velocity. Velocity is how much? That is, we say, sir, 20 meter per second over here. 20 meter per second over here. So can I say this will come out to be, what? We say, sir, it will come out to be 4. Okay. 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 Is this clear? Is this clear? Now guys, tell me one thing. If this is 4 over here, you have to tell me, sir, this is final momentum, this is initial momentum, this is final momentum. I can say in this particular case, this 0 will cancel with this, 2 into 2 is 4. So I can say, what is delta P? Sir, delta P is final momentum minus initial momentum. Final momentum is 0 minus initial momentum in this particular is case 4. So that is, we say, sir, minus 4 is, we say, sir, this. Now let's find the value of force. Sir, force in this particular case will be delta P divided by delta T. Sir, this is 4 divided by, let's take it as mod of 4, magnitude of change in momentum. So we can say that will be 4 divided by, and what is the value of this? This is 0.5 seconds. So it will come out to be, we say, sir, 8. It will come out to be, we say, sir, 8. Is this clear? Yes, lot of students have already mentioned in the chats out there. So answer in this particular case is how much? We say, sir, 8 Newton. Let me show you one more particular question over here. I would want you guys to answer this. A cricket ball of mass 250 gram collides with a bat. Okay. We have got, let's suppose this is a bat, okay? And there is a cricket ball. We say it collides with the bat with 10 meter per second. It is moving with 10 meter per second. It collides with the bat and returns with the same velocity, and then it returns with the same velocity, we say 10 meter per second. So while it collides with the bat, we say it returns with the same velocity. Okay. Yes, force can be negative. If force is negative, means force is applied in the opposite direction. I asked you to tell me the magnitude of force here only. That's why 8 Newton. If you say minus 8 Newton means backward direction. Plus 8 Newton means forward. Obviously, if you catch the ball, so it will apply the force in the backward direction. Something like that. Forget about the negative sign over here. Just the direction. Just the magnitude. Now guys, see, this is 10 and this is 10 over here. This is moving with 10 and then it returns with 10. And you guys are supposed to with the same velocity within 0.1 seconds. So delta t in this cases, we say sir, that is 0.1 seconds. Delta t in this particular case is 0.1 seconds. The force acted on the bat is, we are supposed to find the force acted on the bat. Guys, what is the formula of force? That is simply, that is delta P divided by delta T. This is the force. The first thing in this particular case is, let's find the value of delta P. Sir, delta P will be simply, that is P final minus P initial. And delta P in this case will be simply, sir, P final minus P initial is, we say mass into final velocity minus initial velocity. Mass into final velocity minus initial velocity. How much is the mass over here? That is 250 grams divided by, we say sir, 1000. Okay, because we convert it into kgs. And then final velocity in this case is how much? Guys, initial velocity is over here plus 10. Final velocity over here is minus 10. Why? Because it is moving in the negative direction. So I can say this will be V final minus V initial. So we say, what is the value of V final? Sir, V final in this case is minus 10 over here. This is minus 10 over here. And V initial in this particular case is, we say, sir, minus, and this will be also, we say, sir, 10. This will be also, we say, sir, 10. Is this clear? Is this clear? Is this clear? So now you can do the cancellation over here. Take this negative out. So this and this will cancel. 25 ones are 25 fours are 1 by 4 into, we say sir, 20. Okay. And this will come out to be, we say sir, minus 5 Newton over here, or we say 5 Newton. We say 5 Newton. Okay. If we take the magnitude only, Now, if this is the change in momentum and this is the change in time, guys, could you please tell me 5 divided by 0.1? How much it will be? Sir, force in this case, this is 5. Change in time is 0.1 and this will come out to be, we say, 500 Newton. Is this clear? Basic mathematics is already done. I have shown that, okay, so many times in this particular case, okay. I have shown that in this particular case. Oh, sorry. It is 50. Okay. 5 by 0.1 is 50. So, basic mathematics I have already taken, okay. Basic mathematics I have already taken. One shot basic mathematics is available over there on this channel. You write it, basic mathematics one shot, Yawar sir. Basic mathematics one shot, Yawar sir. Okay. You'll get it. Complete basic mathematics in one shot. Is that clear? Is that clear? Yeah, minus 50, 51 and the same thing, guys. If this is minus, obviously this will be also minus. Minus 50 Newton over here. Clear. Next. Tell me the answer of this particular question. This is easy. Tell me the answer of this particular question that you have got. A ball moves, a ball of mass m moves with a speed v, and it strikes normally on a wall and reflects back and reflects back and reflects back. If its time of contact with wall is t, then find the force exerted by the wall. Find the force exerted by the wall. Sir, what about negative sign? Let me put the negative sign over here. I told you magnitude of force I am asking only. Forget about the direction and all. I see. In this particular case, you guys are supposed to find if a mass with a speed v hits the wall. Okay. Let's suppose we have got a wall over here. And this is the mass which is coming towards the wall with a mass m with a velocity v. We say then it strikes, okay, normally with the wall and reflects back. It is reflected back with the same velocity v. If it is time of contact with the wall is t, delta t in this particular case is given as t, okay? Delta t is given as t. Then find the force exerted by the wall. Find the force exerted by the wall. Guys, in this particular case, could you please tell me what is the value of delta p? Change in momentum. That is mass into v initial minus v final minus v initial. Okay. And we say in this particular case, delta p will be minus 2 mv. Okay. Delta p will be minus 2 mv. Why, sir? Why, sir? Guys, initial velocity is plus v. Final velocity is minus v. So m into final velocity is minus v minus initial velocity is v. So it will be minus 2 mv. Okay, delta p. Now, if I ask you to take the magnitude only, what is wrong in taking the magnitude only, sir? That is 2 mv. Why? Because in the options, no negative sign is mentioned. That's why I told you to take the negative sign. That's why I told you to take it positive. Now tell me, sir, when it comes to the force, that will be delta P divided by delta T. Delta P is 2 mv divided by delta T is, we say, T. This is the force. This is the force. Is this clear? Isn't this visible? Isn't this visible? Okay. This is mass m, velocity v. Mass m, velocity v. It's reflected. So delta t is equal to t. Delta p is equal to mass into v final minus v initial. Then delta p is equal to mass into minus v, because final velocity is minus of initial velocity. Delta p is equal to minus 2 mv. So delta p is equal to 2 mv. So here this is the final answer. Guys, tell me the answer of this particular question. Tell me the answer of this particular question over here. Tell me the answer of this particular question over here. Tell me the answer of this particular question. A 0.5 kg ball moving with a speed of 12 meter per second strikes a hard wall. Okay. There is a ball basically. Okay. It goes and strikes the wall, and this angle over here is 30 degrees. Okay. With the wall. It is reflected with the same speed. It is reflected with the same speed, as shown in the figure. If the ball is in contact with the wall, For 0.25 seconds, here delta t is given as 0.25 seconds. The average force acting on the wall is, means here you have to find the F average. F average will be simply that is delta P divided by delta T. F average in this particular case is delta P divided by delta T. Can you guys tell me in this particular case what is the answer over here? What is the answer over here? Guys, I have told you before, if this angle is 30, can I say this angle will be 60? Because 60 plus 30 is 90. If this angle is 30, this angle is also 60, yes. Now guys, if this is velocity v, if it is striking with a velocity v, it is reflecting also with a velocity v. Guys, remember I told you in this particular case, guys, remember, here vertical components will get cancelled out, horizontal components will add up. Now, I told you in such cases, momentum, change in momentum will be simply, that is 2mv cos of theta. If you remember, in such case, change in momentum will be 2mv cos theta. Now guys, we say this is 2. Mass of the ball is given as 0.5 and velocity is given as 12 meter per second. And cos theta, here we are taking this as theta. So it will be cos of 60 degrees. 2mv cos of 60 degrees. Okay. Now, we can say this will be 2 into 0.5 is 1 by 2 and this is 12. Cos 60 is also 1 by 2. This and 2 will cancel. 2 ones are, 2 6s are. So it will be 6. So change in momentum in this particular case is 6. Guys. This case is exactly like this case. See, I told you in such cases, directly I told you to remember the change in momentum will be minus 2mv cos theta. If we are taking the magnitude only, then it will be 2mv cos theta. So now, I can say in this particular case, we say, sir, force here will be, what is the value of delta P? That is 6 divided by 0.25 will be the answer in this particular case. And if you divide it, it will come out to be, that is 24 Newton. Is this clear? So option C is correct over here. Option C. Next. Tell me guys, what is the answer of this particular question? What is the answer of this particular question over here? What is the answer of this particular question? A block of metal weighing 2 kg is resting on a frictionless plane. Okay. So we have got a block over here. Which is resting on a frictionless plane. And its mass is, we say, sir, 2 kgs. It is struck by a jet. There is basically a jet. Okay. It is struck by a jet. This jet is basically throwing the water on this wall. Okay. Releasing a water at the rate of 1 kg per second. So here it is releasing the water at the rate of 1 kg per second. So I can say in this particular case, dm by dt, that is rate of change of mass water is 1 kg per second. 1 kg per second. Means, guys, what does it mean? Every second it is sending 1 kg of water. It is throwing 1 kg of water. Okay. And at speed, we say 5 meter per second. And speed of this water is, we say, sir, 5 meter per second. Calculate the acceleration of the block. We are supposed to find the acceleration of the block. Guys, see. If we have to find the acceleration of the block, we say as We say force is equal to mass into acceleration. Can I say here acceleration will be simply force divided by mass? If you get the value of force, if you get the mass of block, you will get the acceleration. Now the question is, how much force is acting on the block? So this water is applying the force on the block. dm by dt we know, velocity we know. Guys, see, if mass of a body is variable, velocity is constant. Here velocity is given. dm by dt also in the question is given. We can find the force. So now, can we find the force in this particular question? I can say as F is equal to V dm divided by dt. So what is the value of V? That is 5. dm by dt is, we say, sir, 1. That will come out to be 5 Newton. So 5 Newton force jet is applying on the block. Now let's find the acceleration of the block. So acceleration of the block will be, we say this is acceleration of the block. So that is force on the block is how much? 5 Newton. Mass of the block is 2. So that is 2.5 meter per second square. Guys, tell me in the chats, you got it or not? Tell me in the chats, is this crystal clear or not? Everybody out there, let me know in the chats, guys, if this is crystalline clear. Guys, smash the like button if you have not liked the session yet. I would want you guys to hit the like button as soon as possible. Okay. Now, the next we will discuss over here. That is impulse. Let's finish the impulse first. This impulse, guys, see over here. We say impulse is defined as the change in momentum, or we say short time force. Guys, what is this? What is this? Let's suppose this is a wall. I am applying the force on the wall for how many seconds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I keep on applying the force, okay, for longer time. So this is a long time force. Now apply the short time force. See. I applied the short time force over here. This short time force is what we call the impulse. Okay, he is very impulsive. It's like that. So we say it is also defined as the change in momentum. If you say change in momentum, or if you say short time force, we say it is impulse. Because of the short time force, momentum is changed. Now see. Let me just tell you over here. Guys, see. We say as force is equal to, that is dp divided by dt. I want you to take it over here, multiply this dt with f. So I can say dp is equal to, that is f dt. Guys, what is dt? See, I'll tell you. Now integrate both sides. If you integrate both sides, you will say, sir, integration of dp is equal to integration of f dt. Now, integration of dp is what? Small change in momentum. So if you integrate small change in momentum, it will give you delta p. So it was integration of f dt. Guys, what is this integration f dt? dt is the small time. What is f? F is the force. Means force is acting for the small time. That is what we call the short time force. Force acting for very small time. So that is what we call short time force. And we know this short time force is what we call impulse. This is what we call impulse. So what is the formula? What is the formula of impulse? So I'll write over here impulse is equal to integration of F dt, force acting for a short time, or you can also say it is change in momentum. Why? Because F dt is integration, F dt is also change in momentum. Guys, tell me in the chats, is this clear? Tell me in the chats, is this clear? Everybody, everybody, everybody out there, everybody out there, is this clear? Now see guys, let's suppose I take the graph between force versus time. Let's suppose I take the graph between force versus time. Okay. Like you might have studied, I have the graph between y versus x. So let's suppose the graph is something like this. Guys, have you ever heard that or directly remember it? We say if the graph between y versus x is something like this curve, okay? And I ask you to tell me how much is the area under the curve, this area. You say, sir, this area under the curve is simply, that is integration of y, then this dx, integration of y dx. Area under the curve is integration of y dx. Area under the curve is integration of y dx. Okay. Guys, if it was, let's suppose this straight line, then I would have said area under the straight line will be simply length into breadth. Okay. Because it is simply a rectangle. So it will be length into breadth. But when it comes to this particular case, my dear friends, it is not a square, it is not a triangle, it is area under the, it is basically a curve. Let's suppose if you get a force time graph, something like this, and I ask you to tell me the force exactly over here. I ask you to tell me the force exactly over here. You say, in this particular case, what is the value of area under the curve? Find the area under the curve. Area under the curve here will be integration of this f multiplied by this dt. In case of y versus x, it is integration of y dx. Here, it is integration of f dt. Integration of f dt. Okay. Now, this is, let's call this as equation. First, let's call this as equation second. This is what we call area under ft graph, force time graph. Now, tell me one thing. Can I say from equation first and second? Guys, from equation first and second, we say integration f dt is impulse or change in momentum. And from equation second, we say integration f dt is area. Can I say area is equal to impulse? So we say area is equal to impulse in case of ft graph, that is force time graph. Means from now onwards, if force versus time graph is given, if we have a question in which force versus time graph is given and they ask us to find the impulse, what will we find? Area. Let me show you the question. Let's suppose you guys are supposed to tell me, given the force versus time graph, find the change in momentum from 0 to 8 seconds. Either you say change in momentum or you say impulse. Either you say change in momentum or you say, sir, impulse, because this f dt is also change in momentum. So how do we find the change in momentum? We say, I'll write over here. We say in case of force time graph, we say area is equal to impulse is equal to change in momentum. is equal to change in momentum. Okay. Now guys, let's find the area from 0 to how much it is saying? 0 to 8 seconds. So can I say from 0 to 8 seconds, I'll write it something like this. Area is equal to. First, we'll write the area of triangle. How to find area of triangle? 1 by 2 base into altitude. Base is how much? That is 2. 1 by 2, we say base is 2. And altitude in this case is 6. That is 6 plus this area. Then we say this area. Guys, if the area is from the negative side, we take this area as negative. From the upper side, we take area as positive. From the lower side, we take area as negative. Ibrahim Bhatt in the chats. Hello, Ibrahim. Okay. One of my good students out there. Now, so I can say out here, what is the area under this? What is the area under this line? So area of this, sir, this is 4 minus 2 is 2. This 2 multiplied by 4. That is 2 into, we say, sir, 4. Then we say plus. Then we say plus. We say area under this curve. Area under this curve. So how much is that? That is length into breadth. Length is how much? That is this much is length. That is 8 minus 4 is, we say, sir, 4. 4 into, we say, sir, 3. I'll write 4 into, we say, sir, 3. Okay, and guys, take this area as negative because the lower area we take as negative. Minus, we say 2 into, we say, sir, 4. 2 into, we say, sir, 4. So this is 6 minus 6 and plus 4 into 3 is 12. So in this particular case, change in momentum will come out to be, we say, 12. Is this clear? Please tell me in the chats, everybody out there. Guys, is this clear? Okay, is this clear? Okay. So we say, guys, this is 6. 4 into 2 is, okay, this is 8. 4 into 2 is, we say, sir, 8. So how much it will be? This is 6 minus 4 into 2 is, we say, sir, 8 plus 4 into 3 is, we say, sir, 12. Now, 12 plus 6 is, we say, sir, 18 minus 8 will come out to be 10. Answer in this particular case is 10. Okay. And guys, what is the unit that we can use over here? We say impulse is force multiplied by time. What is the unit of force? That is Newton. What is the unit of time? That is second. I can say NS. 10 NS. Is this clear or this is super clear? Great. Okay. Next. Let's suppose you get a question something like this. Sure, guys, in this particular case, we say force versus time relation is given. Then impulse as a function of time will be. See. We say in this particular case, here, force is given. F is equal to, we say, 500 minus 100t. This force is given. And we are supposed to find impulse. I'll write to find impulse. Guys, let's suppose we have got a block over here. And on the block, we are applying force. We have to find impulse. Guys. We know impulse is simply integration of F dt. Means if force is given, you have to find the impulse. What will you do? You'll do the integration. So we say impulse is integration of. Force is simply over here, that is 500 minus, we say, sir, this is 100t and then I'll write over here dt. You have to do the integration. So can I say in this particular case, I is equal to, guys, integration of 500 will be how much? Integration of 500, let's suppose I have got, this is 4 integration of 4 dt. We say 4 we will take out and then integration of dt. This and this will cancel, so it will come out to be 4t. Similarly, if you have got 500 dt its integration. 500 is constant, take it out, integration, we say dt. This and this will cancel, so it will come out to be 500t. So I can say in this particular case, this will be integration of 500 is 500t minus integration of 100t. Guys, see, this is integration of 100t and then we say dt. 100 is constant, take it out, so this will be 100 integration of t dt. What is the integration of t? Integration of t will be t raised power 1 plus 1 upon t raised power 1 plus 1. So that will be 100, we say t square divided by 2. That I'll write over here, 100 t square divided by 2. Okay. So this will come out to be, that is 500t minus, we say sir, 50 t square. So this is the relation of impulse. So if force is given, you are supposed to find impulse, you will do the integration. That is the simple normal method. That is the simple thing you guys are supposed to do over here. Now guys, this is the question that we have. A ball of mass m 1 kg is moving horizontally with 10 meter per second. After striking with a vertical ball, it returns with a speed 5 meter per second. Find the change in the momentum of the ball. Find impulse. Guys, this you can do. This I'll give you as homework. Okay. I would want you guys to solve this particular question from your end, and do let me know the answer of this particular question do let me know the answer of this particular question in the chats. Sorry, in the comments later on. Do let me know the answer of this particular question in the comments later on. Guys, hit the like button if you have not liked this session yet. I would want you guys to make it 200 right now, right away. This. Okay. So guys, with this we'll basically end the today's session. So in the part 2, we will be starting with the rocket propulsion. We'll be starting with the forces with the forces and mechanics like weight, normal force, tension. All of these we'll be studying in the next class. And before leaving, I would want you guys to know one thing. That is, once I end the live session, afterwards you guys are supposed to comment over there. Let me know how was the session, okay? Because we keep on reading your comments every single time. How is this session, okay? So it gives us a good feeling when we read all of those good comments from your side. So that's all for today, my dear friends. That is, we say, sir, thank you. Okay, and this is from my side. So see you guys at the next session. Till then, bye-bye and take care. And let me just tell you something very important. We have recently launched this Phoenix Pro batch. That is already started. I have taken 2 classes, okay? But Wasim sir will be starting from tomorrow onwards. So I would want, if any of you is preparing for NEET 2025 and he wants the top-notch content, he wants the brand new test series, he wants the complete study material, complete personal mentorship, then this batch is for him. So price is right now at 5,999 rupees. Lot of students have already joined. The link is in the description of this video. Click onto that link and join this session, and see you guys in the session. See you guys in the batch itself. And there is Unacademy Pro also. Guys, I would want you guys to comment later on in the comments out there once I end the live session. So there is Plus subscription, Iconic subscription, and Pro subscription. What is the difference? Lot of students want to learn in the online batch, but they want to give the test series offline. They want to solve the doubts in the offline center. They want the revision classes in the offline center. That is possible with the help of this Unacademy Pro. This is the difference between, we say, Plus, Iconic, and Pro. You can clearly see over here the difference between Plus, Iconic, and Pro. Okay, so these are the features, and accordingly you can take your subscription. I would want you guys to basically think about this and then go for the subscription accordingly. And most importantly, guys, listen to me very carefully. See you guys in the next session. That will be the part 2. In the next part, we'll be completing this particular chapter only in 2 parts. Okay. So till then, bye bye and take care. Thank you so much. See you guys very soon. Okay. It will definitely help because I teach good, as you guys say. Thank you so much. So take care and bye bye. And do let me know in the comments how was the session. Okay. Open your heart in the comments out there. Okay. By writing those comments. Take care. Bye bye. See you guys very soon. Take care. Chill pill. Thank you.